Hello and welcome to your second lesson on moments, talks and couples. Last lesson yesterday we looked at moments and the principle of moments with the body in equilibrium. Today we are looking at talks and couples. So I thought I'd start off with a definition. A couple is a pair of equal and opposite forces acting on a body but not in the same straight line. Now what I mean by that is if you it's not going to let me draw on this now, hang on, I'm going to scroll down to the bottom. If you had a straight line here and you had 10 newtons going up and 10 newtons going down at the same point, it would do nothing. That's not a couple. However, if you had 10 newtons going up here and 10 newtons going down there, that will cause a rotation. That is referred to as a couple. You've got equal and opposite forces, but they're not on the same line. So going up. The torque, unofficially, is the moment created by that couple. But again, in an exam, if you are asked for the definition, please give the equation. So the official one is one of the forces times the perpendicular distance between the forces. And I've written that in symbols. You'll notice I've used the Greek letter tau for torque. Now that is not officially in your textbook. They just refer to torque. So you'd have to write torque every time you wanted to do it. But I am lazy and I know that torque is denoted by a tau, so I've put it in there. Feel free to carry on just writing torque if that's what you prefer. So I've done an example question. Here we have a disc which is being rotated by two 10 Newton forces which are separated by 76 centimetres. To work out the torque, I do one of the forces, 10, times the distance between them, 0.76, which gives me 7.6 Newton meters. Then I've done a slightly more complicated question. So here you've got a bar which is attached to a disc. Now the bar has got a couple acting on it of 100 Newton forces and it will rotate as a result, but you might not want it to rotate. And so the disc is there and a rope attached to prevent that rotation. So the question says, how much tension T is required in the rope to prevent rotation due to the couple? That'd be the. So first thing I'm going to do is work out the torque of the couple, which is 100 times 50, 50 centimetres is half of the distance, so the total distance between them is 1, so it's 100 Newton meters. Now I'm going to treat that as the torque that is going to, or should I say the moment that's going to have to be created by that by the tension force. So tension is moment divided by, not force, sorry, moment divided by distance is 100 divided by, and it's 15 centimetres, so 0.15, pop that in my calculator, and it gives me 666, well, 0.6 recurring really, so let's call it 667, shall we? And it's a force, so it's newtons, and that's it. So I hope that made sense. I shall see you on Zoom later where we'll do some questions. Bye.